Hey, good afternoon. I'm Adam Debus. I am a staff SRE at LinkedIn. Before joining LinkedIn 3 years ago, I spent more than a decade working in the e-discovery and legal compliance fields, where I led a team of systems engineers, both in managing our worldwide data centers and in product development. While at LinkedIn, I've had the pleasure to work on some really exciting projects. Most notably, our fleet compliance initiative, where we're taking a holistic view of our entire operating system lifecycle and really looking at what that looks like from image creation all the way through to deployment, as well as post-deployment issue remediation and management. Today, I'd like to talk with you about the philosophies behind one specific portion of that lifecycle, the OS image certification process, and how we're approaching this very complex problem. Also, while my contact information is on the screen, I think I'm legally required to tell you that you can connect with me on LinkedIn using the QR code or the URL there. So first, just a quick overview of what we're going to talk about today. I want to go through the motivation of why we're looking at this now, followed by a discussion of some of the ways that we're looking to address this very complicated problem. Following that, we'll take a quick look at some of the early results we've seen, just a really brief overview. And then I have some final thoughts that have really been rattling around in my brain about this whole process. It is important to note that I'm not going to dive into specifics of the technical implementations that we're doing. LinkedIn's environment assuredly looks different from your environment and from the environment of the person next to you. And so the specifics of how we're choosing to write our code and test our environment are less important than the philosophies that we're approaching the problem with. So LinkedIn obviously has been around for about almost 20 years. And we obviously have had a process for this. So why are we looking at it now? What's changed? Well, the first thing is that LinkedIn's grown a lot. So when I was creating these slides, I went, oh, I want to get the last decade's worth of data. And so naturally, my brain in COVID haze went back to 2010. So all of my stats are going to be 2010 through 2022, and we're just going to call that a decade. And LinkedIn has grown from about 65 million members to 800 million members over that time, a 1,200% growth. And that's really impressive and really great. But our infrastructure in that same time span has grown by about 6,000%, 5 times faster than our member growth. And that seems weird at first blush, right? But we've introduced a lot of new features, things like LinkedIn Learning, many of our AI-driven algorithms, expanded resources for recruiters and salespeople. So there's a humongous amount of growth there, and with that growth comes a lot of additional complexity that may not have been accounted for the last time we looked at this problem. The next thing, there we go. The next thing is that in 2019, we announced a multi-year migration to Azure. You can find out some more information about this at the URL. That'll be included in the slides that are published. And as everyone knows, when you want to get up and migrate an environment to the cloud, it's super easy and you just pick it up and move it, right? No. Moving things to the cloud requires an entire paradigm shift in the way you think about your server and application environments. And that even extends all the way down to the operating systems, the way you build and deploy your operating systems. And this gives you great flexibility. The cloud is wonderful for giving you tons of flexibility, coupled with a tremendous amount of complexity. We also ran into, in back-to-back really, 2 big kernel issues. These were really impactful for LinkedIn. The first was in how the kernel itself handles memory pages and freeing those memory pages when a large memory page is requested. One of the things that older Linux kernels didn't do well was free memory. If you needed a large memory page, something a megabyte or larger, The kernel, if the system had been up for any length of time, and by any length of time I mean like 6 to 8 hours, your memory pages were incredibly fragmented. And to free up that memory, you had to drop all the memory caches, all the page caches, and then let the system rebuild them, which creates a huge long tail problem for any I/O-intensive application that now has to go back to disk for every single I/O access. The second one, once we finished remediating the memory handling issue, the second one happened almost immediately after. We upgraded the kernel, got into a new kernel, everything's great, and turns out there was a bug in the 4.19 kernel in the ext4 file system driver that, under certain combinations of hardware, coupled with an ext4 file system and certain I/O workloads, would cause a significant degradation in I/O performance until the I/O queue cleared and that particular pattern went away. LinkedIn pulled the handle on the slot machine and came up all lemons. This required a tremendous number of kernel rebuilds over a very short period of time while we bisected the kernel to find the specific commit that caused the bug and then work with our Microsoft Linux kernel partners to figure out a remediation, get that submitted upstream. We probably went through 75 to 100 kernels in under a month. It was a lot of work. But both of these issues required that process of build a kernel, test it. Then if we think it's a release candidate, throw it in our production environment or our QA environment and see how it reacts. And sometimes it would make it all the way to production before we found that nope, still hasn't fixed the problem. So we obviously needed to take a harder look at this process and how do we prevent that from happening. This one's a fun slide. I like these stats, not because they're good stats, but because they really illustrate a really interesting trend. We've heard a lot over the course of the last couple days, software runs the world and increasingly is doing so, but as we all use more and more and more software, we find more and more problems with software. So this chart represents the number of CVEs opened every year in the last decade, since 2010. And a couple of things really strike out at me about this. One, we're seeing an average of 65 new vulnerabilities a day, and these are just the ones that get a CVE. If you think about all the bugs and all the security problems that get fixed without there being a CVE involved, this number increases exponentially. The other thing that really strikes out at me is that the number of CVEs opened every year has increased by over 400% since 2010. That's very representative of the software environment we all exist in today. Now, the one last thing that jumps out to me about this is that gigantic jump between 2016 and 2017. A couple of things were happening there. One, the entire world was starting their cloud migrations. We've done with the early adopter phase, it's been proof of concept, and now everyone and their brother is trying to migrate to the cloud. This introduced a ton of security vulnerabilities as people reworked their paradigms. The other thing that happened was MITRE changed their parameters for what got a CVE. They widened the scope of what they considered for issuing an advisory. But what that really means is those numbers in 2016 and before are not actually representative of the bugs and the security vulnerabilities that were out there. So as you look at that 2016 number, that probably should have been about 2.5 times higher based on the new criteria. So with all of these issues coming up, we have to be able to respond faster. There's more bugs, there's more security problems, we have to be able to respond faster to that. And finally, there's the human cost. I like using the image of Sisyphus to represent toil. I think he's the patron saint of toil. And what happens over time is as your processes age, and this is probably not anything new to anyone in this room, as processes age, they get used less. The pace of innovation outstrips the support processes behind them, which is something I'll talk about again in a little bit. And you get more and more manual processes involved in these certifications. And then every team who's involved, well, they have different levels of automated work versus manual work, and nothing standardized across the platform. So you still get high quality results. It's more dependent on the people doing it, but you hire good people, you get good results, but you have dozens, if not 100 people, especially in an environment the size of LinkedIn, who are consistently having to drop what they're doing in their development work to certify a new OS, and that's not sustainable. So how do we approach solving this problem? And the first thing I have to do as I looked at this issue was, okay, what is the scope of what I'm trying to solve? And I started looking at our environments and our applications. And like many of you, at LinkedIn we have two general classifications of applications. We have our stateless applications, the things that we can easily scale up and scale down, don't maintain any data, they just process and move it along, right? And then we have our stateful applications, databases, AI engines, searching, message queues, all of those things. But as you look at that, that's not really a binary state. You have stateless applications that have stateful aspects. You have stateful applications that have sidecar stateless applications, like router applications for databases. And then as we continue to look, our hardware environment is very diverse. We've got our on-premise data centers that we've been running for many years now, and we've got this Azure migration going on. But that's not really binary either, because you get applications that have to span both of those environments. So as we end up looking at this, we find that a stateful application that's running in Azure has dramatically different testing requirements than a stateless application running in an on-premise. And similarly, a stateless application running in Azure is different from all of those as well. OK, so my big problem has just sort of gotten bigger, right? Or at least more complicated, which is a theme that happened a lot at the beginning of this process. So this introduced the layer cake of certification. And all of you are sitting out there very confused as to how cake applies to this. So one of the things that is really important in a certification process is that you have to have an implicit trust in the tests that ran before yours. Really a certification process is one long DAG with decision-making in different branches and trees, but it's ultimately a singular process that that happens in sequence. And if something early on fails, it can affect everything that happens after it. OK, and I was looking at our tests, and as I start to map out what tests we have a lot. I can start categorizing them into different buckets. So there are tests that fall under the category of infrastructure. And then there are tests that fall under the category of tooling. And then in our environment, at least, we get to a final layer of applications. And I start bucketizing all of these things. But I still have the problem that there is the tests that run in our on-prem environment are different from the tests that run in our Azure environment. And this is sort of where the layer cake example comes in, because when you're building a layer cake, there's two important things to know. And if you ever watch Food Network or bake yourself and watch a baking competition or whatever, there will inevitably be the one guy or woman who mistimes everything, and either the cake comes out too dry or the cake comes out underbaked. But he still has to present something. And he starts to build his layer cake, setting down his base foundational layer, which he knows is not stable. And then he'll put the frosting on it. He'll put the second layer on and the third layer on. And then just before the judges go to view it and judge it, the whole thing falls over. Well, the same philosophy really holds true with these kinds of certifications. If your infrastructure layer isn't tested well, comes out underbaked, can you really trust the results of everything that's built on top of it? The other advantage that the layer cake analogy has here is that we don't have to use the same flavor sponge at every level. I can start mixing and matching and start categorizing all of my tests into different forms of these layers, and I can start now addressing each of these tests in a single brick, if you will, instead of, we're lumping things that are similar to each other together, instead of trying to handle everything all at once. And so that means that I can take my on-premise vanilla sponge at the infrastructure level, and then, oh, well, the stateful tooling is slightly different than the stateless tooling, so I can swap in a chocolate sponge for the second layer, and then I'm specifically testing on my SQL database, and I can put a strawberry layer on top. And then when I frost it all, I'm really stretching the analogy here, but bear with me. When I frost it all, that's the automation holding it all together. So, this has been a long-standing thing as I've been trying to advertise this, and now I just go with it. But let's talk a little bit more about the 3 stages. So at the infrastructure level, what we're really trying to dive into testing is our hardware testing. Is the new operating system snapshot and image that we've created compatible with the dozens of different hardware configurations that we run? And that's just in our on-premise environment. Some of these machines are years old. We're buying machines all the time. We all know how fast the hardware technology has been advancing. All right, does it run the way we expect? Does it even boot? Then we test for third-party driver support. You buy hardware that is not standard, and you end up having third-party drivers. Well, those need to be validated as well. And then performance testing. Sometimes you can catch some of these problems really early by running hardware-level performance tests. Can we validate that the new OS snapshot, the new kernel, is performing with similar or better speed on the same hardware configuration as the last one? And we automate all of that. And we perform a statistical analysis to make sure that, yes, okay, some variation is natural. You're never going to get the exact number 2 runs in a row. But we take the human element out of analyzing those results, and we run it through a statistical analysis. We harden the system with our standard information security policies and do vulnerability scanning. Sometimes, those packages from the distribution, they come in, even though they're brand new, a CVE was opened 2 days after they were published to the repo. We need to be able to catch that because we have to make sure that we're secure before it rolls out. And any specific environmental tests. After we get done with that, we move on to tooling. We look at our deployment pipelines. We look at our configuration management. We take each of these components, containerization, firewalls. One that didn't occur to us early on but became increasingly important was language frameworks. Your Java, your Python, your Go. Do those environments continue to work as well as they did on the previous known good snapshot? Because I assume all of you have similar environments where, half my applications run on Java. If Java itself is not performing the way you expect, all of the applications that run on it also will fail or be at a degraded performance. So we throw language framework testing in here. We do synthetic testing. Now we take all of these components, we put them together, we test the full deployment pipeline with a no-op application. Can we get something out there? Does it report as healthy? We don't want to push member traffic to it yet. Just say, can it launch? Is it healthy? We also look at synthetic testing for previous root cause analyses. We had an issue in the past. Can we make sure within a reasonable level that it's not happening again? And as we continue to have more root cause analysis, we should continue to build more tests to catch things in the future. Finally, we do application testing. Once we're confident in our tooling, we're confident the operating system is running the way we want to at the infrastructure level, we take real applications that have volunteered to be our canaries, and we deploy them side by side on a known good certified snapshot and a new snapshot. Your traditional A/B testing with a little more risk. We then push actual live member traffic at similar levels using our load balancing technology to both instances. And we again do statistical analysis on the key metrics to make sure that instead of before where usually someone is like eyeballing a couple of graphs, we're actually doing real analysis on that data. And we say, is it performing as well or better? Better is always the hope, but there's only so much you can do. Similarly, stateful applications tend to not follow the same guidelines when they're being tested. So we partner with all of those stateful teams to design custom pipelines to make sure that our stateful applications are working correctly. And that brings up a good point. Partnerships are absolutely essential. You know, especially in an environment as large as LinkedIn, but I'll tell you, even in environments, in much smaller companies that I've worked, there's no one person, or there shouldn't be one person, who knows everything about everything. And in my experience, if you find someone who claims to know everything about everything, run as fast as you can. But the way we've approached this issue is that we, instead of saying, OK, we're going to create the automation platform and we're going to create all the tests, we said, no, we're going to create the automation platform. And we're going to partner with the people who are experts in all of these technologies to create and own the tests for their technologies. And it's a symbiotic relationship. We went to them and said, look, we think we've developed a really flexible automation platform and framework that you can use to write your tests. You can do anything you want. You just need to call these 3 functions. And then they tell us when there's something in the framework that isn't working for them or it's missing a feature. And it creates a constant feedback loop. And what we say to them is, OK, you're going to own your test. As you evolve your product, as you evolve your technology, you'll maintain that test. And then when it fails, we'll let you know. And you will be responsible for telling me if it's the test that failed, in which case you'll update the test to be accurate again, or if it's the environment that failed, and we will coordinate a response to that to fix whatever the problem is. And again, that symbiotic relationship with all of these different teams is so important. You will not succeed in this kind of a endeavor without getting multiple people on board or multiple teams on board. So where has this led us? Well, in the 9 months that we've been in production, we've seen a total time to certify a new OS snapshot reduced by 70%, which is enormous, but it's only the tip of the iceberg. Unfortunately, my gains are going to be much smaller going forward. We've seen a significant reduction in manual testing. Teams have had to put in that initial investment, but then they're much more hands-off, which makes them happier. And it's the same testing process over and over again, which means it's defensible, which makes me and information security happier. And we've also added new testing paradigms, taking a lot of this analysis out of a human needs to look at it and decide if it's good or not, and moving it into a statistical analysis engine has really opened up a much broader ability for us to look at the data and make decisions. So some final thoughts that have come to me over the course of this whole process. The first is not going to be a surprise to anyone. We've all heard it. We've all encountered it. We've all said it. Scope is important. And it was really easy for us to lose sight of scope in this project. Coming right on the heels of those kernel issues, the original mandate was, we need to test the kernel. Well, you start diving into that problem, and it turns into, well, I need to test the OS. And then you have lots of meetings and lots of arguments about what the testing the OS actually means. And you end up where scope creep is a constant presence. Everyone has an idea that they want to test. Everyone has something that they want to shoehorn into this brand new automation system that looks like it's going to solve all of their problems before one line of code has ever been written. And you have to find that Goldilocks zone. Narrowing down the scope of what you're trying to accomplish, especially in a project this large, is so important. And the best way I've found to help guide you to where your scope needs to be is to define a core purpose for your application or for your project and constantly be asking yourself, is this feature, is this request in service to my core purpose? And the core purpose that we came up with for this project was develop a comprehensive, automated, extensible, and defensible OS snapshot testing process. And don't discount how important defensible is. Coming from my legal background, or background in legal services, the idea that I should be able to take a snapshot and run it against the same version of all of the tests that ran on it the last time and get the same results is so important. If you can't repeat your test, then your test is meaningless. And that also leads us into, you absolutely have to integrate a regular evaluation of your processes. I mentioned earlier, the pace of innovation is outpacing the growth of the support structures supporting that innovation. It's so easy for everyone to want to develop the new thing. Keep pushing things forward. And we don't put enough investment in the underlying technologies that validate that the new things are working and are stable. So you really have to put that investment in and make sure that you're supporting the new technologies. Because if you don't, you get gaps in certification. You get manual processes, which turn into toil for teams. You get no longer relevant tests, which turn into tech debt. And as all of these things build up, you end up having to do this project all over again. Something else that I've really been thinking a lot about, again, coming from a compliance background, working heavily with our information security teams, is that information security compliance is really easy to think of the information security department as, if not the enemy, at least working against the overall goals of the organization. And it's really important to have a secure and compliant environment, especially today. If it wasn't like 25 slides back, I'd go back to the graph showing the increase in CVEs. But you have to build a partnership with your information security team. You have to have them involved, and you have to build a secure environment. Because we focus a lot on the R and SRE, reliability, resiliency, but I propose that we can't have a reliable or a resilient environment unless the infrastructure that we're building on it is secure. You have to have that compliance in order to have resiliency and reliability. And finally, this is a big project. I can't begin to tell you how big, we will never finish this project, and that's by design. We should always be looking to expand the scope of our partnerships and of our testing infrastructure. But what's really important is that investment has to come early, and you have to keep making that investment. And that will overall reduce your ongoing costs, the human costs, the monetary costs, and the reputational costs. We see what happens every time one of the major cloud providers has an outage and half the internet stops working. It's a huge reputational hit. I'm not saying that those outages are information security related, to be clear, but they can be. And so it's really important to have these investments happen regularly. You have to set up a shared responsibility across the organization. People have to be responsible for their technologies. And it's really important to have an integration with your postmortem and your new project processes. You need someone going, hey, this looks like something we can test for. Or, hey, you're designing a new technology. Let's make sure that you're putting that investment up front so that we're not trying to backfill this later. Because if you design it from up front, it's going to take less time and cost less than if you try and backfill it. And with that, I have 2 seconds left. And I just want to say a quick thank you. I'm a huge proponent of credit where credit's due. This is my core team at LinkedIn who is working on the automation platform and various pieces surrounding it, from systems engineering all the way through to OS deployment. So I just wanted to make sure that I shouted out for them, because none of them could be here with me today. And thank you all very much for listening.